Good morning, good afternoon, and good evening, wherever you are. Thank you for joining. At CIQ, we're focused on powering the next generation of software infrastructure, leveraging the capabilities of cloud, hyperscale, and HPC. From research to the enterprise, our customers rely on us for the ultimate Rocky Linux, Werewolf, and Aptainer support escalation. We provide deep development capabilities and solutions, all delivered in the collaborative spirit of open source.
Hello. We are back live. Hey, guys.
Happy 25, everybody.
Yeah, it's incredible. Wow, Dave, do you have a new microphone? This feels
way
all...
new setup.
Yeah, dude. What's up?
Yeah, I've been recording a bunch of demo videos. And so, I mean, I've got a new mic. I got a new webcam. I have a key light. I've got some ambient lighting. I've got a green screen I can whip out if I need to.
It's amazing.
I see a glow on your face. Do you have your light on right now?
I do, yeah.
That's awesome.
This is just me. I just glow.
Oh my goodness, that's wonderful. It is so good to see you. So welcome everybody. We are back live. Yes, we are so excited to be here. Today we're going to be talking about HPC in 2025, trends, technologies, innovation shaping the future. Very excited. So we might want to just do a little intro, though I think that we've all been on here several times now. So I'm Rose Stein. I work at CIQ in the sales department. Nice to see you all. Zane.
I'm Zane Hamilton. I've been at CIQ for a long time as well. Been doing this for a while, and I'm in sales also. Jonathan. Yeah. Tap people and go in a circle here.
Yes, I'm Jonathan Anderson. I'm on I think we call it the performance computing team here at CIQ as an HPC engineer.
Sounds right.
Dave, I'm passing it to you now.
I was going to say, no, I said my name. Yeah, I'm Dave Godlove. Yeah, I've done a bunch of stuff at CIQ. Currently, I'm the technical product writer, and I am working pretty hard on documenting everything fuzzball.
Ooh, so yes, thank you so much for that. That's actually really exciting because there's nothing more better. There's nothing better than having to do documentation and writing about something to really learn it, right? Isn't that what they say? The ultimate way to learn something is to teach somebody else.
Teach it.
Yes, absolutely. So
yeah, absolutely.
And that kind of goes into a little bit about what's coming up, I believe, next week. So this time next week, you are hosting a Fuzzball webinar, yes?
I am indeed.
Tell us a little about that.
Yeah. So, right. So as you kind of said, one of the best ways to learn a new product or learn a new skill or whatever is to, document it. And so that's one of the reasons I jumped at the opportunity to kind of have a full-time gig, digging into all the corners and nooks and crannies and things of Fuzzball and documenting everything because, Fuzzball is about to take over the world. And, so being positioned as like one of the people who kind of knows Fuzzball the best at the beginning is going to be an awesome position to be in. But yeah, so the webinar next week, we're going to go over and talk about really what Fuzzball is. We're going to introduce some of the, things that you can do with Fuzzball based on, different types of workflows and stuff like that. We're going to get a little bit more advanced, and we're going to preview and kind of tease a new feature that we also showed at SC. And that is something that sits on top of Fuzzball clusters and essentially makes the clusters like one big meta cluster, and that's called Federate. And so the idea there is that instead of interacting directly with any particular cluster, be that on-prem or in one cloud or another, I can just have this thing sitting on top of all the clusters and interact directly with it, send it my workflow specifications, and it'll figure out, which cluster is best to submit my workflow to and go ahead and submit it.
It's exciting. I'm looking for that very excited to see that for a long time.
We are very excited. Alan, we are so excited you were here too, but I just wanted to say one last thing about Dave's webinar that's happening next week. It is a gated webinar, meaning that you just have to sign up for it. So there's going to be a link in the chat right now to sign up for that webinar next week. So it's going to be on Zoom, which is a little bit different, which means that when you sign up for it, you actually get to be live in the Zoom room with Dave. So that is very exciting. And thank you so much for taking your time to do that. Alan, welcome to the party.
Hello there.
Hi. Want to say hi to the people and tell them who you are?
Alan Sill. I run the High Performance Computing Center at Texas Tech University, and have too many other diversions for my time. Notably, I run an industry university cooperative research center in cloud computing that is focused on data center control. We're really busy these days. And I'm now, as of a couple months ago, a couple of you know, co-director of a new project focused on renewable energy powered data centers.
Awesome. I have so many questions about that, but that's for another minute. In this very minute, I would like to thank Jonathan Anderson for doing a similar type of webinar, but on a different topic, werewolf, last week. And from what I hear and what I experience, it went very well. You want to talk a little bit about that, Jonathan?
Yeah, so I mean, a lot of it was werewolf overview stuff again. But in particular, we get a lot of questions about running GPU nodes, particularly NVIDIA GPU equipped nodes with werewolf. And there's been some confusion about what you have to do in order to make that work. So we demonstrated a couple of different ways to build GPU driver equipped node images, and then the steps you have to go through to provision those out onto compute nodes and run GPU jobs on them.
Yes, thank you for that. I got actually a couple of emails thanking me to thank you for that webinar. So
Yeah.
Publicly, thank you, Jonathan.
Yeah, it's a lot of fun. And we got some good response both in the webinar and after the fact, some people following up and asking more questions. So yeah, it's always good.
Jonathan, if they go sign up for that now, can they see the recording?
I think it's just public now.
It's public now.
Okay.
Yeah.
Can we post that link? That would be fantastic. I've had a few ask.
Oh, yes, that is a good point. It is definitely on our YouTube. Yeah. And they'll be doing that right now in the little link
Perfect.
below. Yeah. And if you can't make the fuzzball one, it will also be live later. But you can actually be in the Zoom room with Dave Godlove next week at this time. So that's kind of what makes it a little bit more special.
Yeah. So make the live one.
Make the live one.
It'll be live later.
Dave needs that question.
Previously recorded live. Exactly. Awesome. Okay. Well, Alan, I mean, you are in the right place for what you are working on to be able to brag and talk about it and share about it. Specifically, as you know, the title of this particular get together is, HPC in 2025 trends, technologies, and innovations shaping the future. So would you like to talk a little bit more about the cool stuff you're doing?
Well, so I'll preface this by saying that I believe we will see that AI is in a lot of our answers. But that leads me to answer your question, which is I'd love to brag, but my current mood is more one of panic.
Okay, that's fair.
Alan, you love AI. What are you talking about?
Because specifically of this AI stuff, it's like we were doing pretty well. We're kind of migrating towards, Google was advertising, Azure was advertising, everybody's advertising, we're buying renewable energy, we're not killing the planet and stuff. Then AI come along and they said, hell with that. And let's just build hundreds of billions of dollars of new data centers with any power source they can. So we had proposed this project years ago to focus on, essentially what the project is to focus on the remote management of data centers and the treatment of data centers. Imagine an API for data centers. What needs to be in place for that to work? And that's been our focus for a decade in my industry-driven center. We had a lot of nice cooperation with industry trade groups and large-scale companies who don't mind spending a little bit of money in a university setting, but focusing on the instrumentation and the what's necessary to go from managing a node or a cluster into using those same techniques, the exact same techniques, to manage the equipment in data centers, HVAC systems and power delivery systems, and all the many parts that have to work. So that's been our focus, and we wanted to prove it in the context of a renewable energy powered project that we have at the university that was sort of finishing its life. It was focused on integrating different sources into the electrical grid, and we said, let's put a data center there. And so that's our project. And what I believe is that we desperately need this, hence the panic, that the right way to deal with this, I don't think there's any one solution. One solution would be to build computers that draw less power, please. But in the absence of that, what else can we do? Well, it helps if we can migrate the data centers to where the power is cheap and abundant and preferably renewable. Fortunately, those things do go together now. The cheapest form of power there is renewable energy at its source. So then you have to deal with variability. Batteries help, but what you can get from this is that it has to be remote. So I feel like 10 years ago, we started working on a project that is now of immediate concern. And the only question is, can the field do things in time to blunt the tremendous environmental impacts of these large scale data centers? So are you panicked yet? I'm panicked.
I don't
Try
know
not
that I
to be.
would say I'm panicked, but when I was looking through the list of discussion topics, one of them was like energy efficient computing or something like that. And all I could think of was, yeah, people aren't going to do that. They're just going to keep building big, power hungry AI data centers. So I'm glad that you're thinking about this and helping at least
Yeah.
provide the tools for it.
In HPC Wire today, there was actually an article from HLRS, the German supercomputing outfit. I'm a big fan of theirs, by the way. They do some tremendously good work. And they had been, they were publishing the results of an HPE power capping software suite. Unfortunately, they didn't publish the software, but on their large Hawk, and they have two new computers, they've actually implemented this software that essentially does power capping and load leveling. It is certainly possible. And more generally, energy efficient HPC. Well, so a lot of attention can be paid to making the algorithms more efficient. I'm going to give you an example. Your cell phone. There's a whole lot of energy efficient computing thought that goes into how your cell phone works, and that same pressure is now on the AI industry. They just want the models to. They want to run more models, so they need the models to be more efficient. So you shouldn't give up. So panicked, but not despairing yet, I guess is what I would say.
I am interested in like your experience and your perspective on the incentives for at the software level, the software being power efficient versus programmer efficient. And it feels like, when I first got started, it was all about being efficient with the resources that you have. But the perspective for a while now has just been that the resources, the computation is so abundant that people just want to write in the highest level language with the most comfortable or most I don't know, most meaningful semantic to them, and efficiency and optimization is like a distant second place. Do you see that changing, given experiences that people have with mobile computing, and now there actually being power constraints with the AI industry, or are there more pressures that are going to have to come in to incentivize kind of large rewrites of some of these applications?
I want to get Dave and Rosa and Zane's take on this too, but to some degree, things are running at cross purposes, right? You could make the argument that the whole industry is trying to make programmers unnecessary through AI. We might have our own opinions about that. Some of them might be well founded. I'm trying not to be too pedantic about this, but yes, there's some hope that coding efficiency can be improved through AI techniques, not the ones we have now, but yeah. Think of the low code movement, for example. It's been around a long time. There's always been this low code stuff. Drag a few icons around, you have a program. That's going to be revolutionized by AI methods, right? So maybe it's not the stuff that hardcore hackers. I like to think of myself as one like squeezing every bit of efficiency out. But I will say that the incentive is there to squeeze out the efficiency because the scale of the problems people are trying to attack. Again, my reference goes to the cell phone. You need it to be more efficient because you want a lot of power in a per unit compute, right?
Mm-hmm.
I'm hoping to see that the models getting built are built around more efficient language or more efficient code in the models themselves. I think right now it's very generic and it just tries to build the thing that solves the problem. But if they could start building models that actually take into account really, really well written code to take advantage of this stuff, that's what I would be really interested to see and how we're going to get there.
Yeah, so I put a link to the HLRS stuff and our project, the 5-year project, and most of it will be focused on these topics. What we're really going to be doing is we're focusing on the scientific computing arena. We're not going to try to solve the whole problem. We want to focus on what does it take to get scientific computing, academic computing, to make better use of co-location and remote operation. The expensive buildings on university campuses are not the right place to put data centers, but we persist in doing that. Our project is to be focusing on what does it take, what incentives do you need to put in place to get scientists, engineers, academics to move their computing to more efficient locations, more low carbon locations, happen to be cheaper energy and so forth. Renewable energy is variable, but on a broad scale, Dave was talking about fuzzball, and congratulations for reinventing the idea of grid computing, by the way. Happens about once every 3 years. We called it cloud last time. Maybe we'll call it fuzzball going forward. But distributed computing and variable power sources go together. And not just for climate reasons. When the war in Ukraine started and there was a panic about Russian oil supplies to Europe, the energy prices skyrocketed. And we got lots of calls from our colleagues in Europe saying, we can't afford to pay our electric bills. Can we move some of our computing to your machines? So this is actually the old idea of grid computing. And it does resurface every now and then. But if you now think about mitigating carbon impact by moving to where renewable energy is abundant, it makes a lot of sense. So that's the other aspect of renewable energy. People tend to think in terms of constraints. I only have so much energy. At least as an important consideration is abundance. When the sun shines, there is actually lots of solar power, and there's 20 gigawatts of solar power in the state of Texas alone. And batteries are going in hand over fist, 15 gigawatts of wind. But so if you can move the compute to where the power is so abundant that it's actually sometimes negatively priced, then you can actually make an economic argument for doing the right thing from a climate point of view.
Dave, before you jump in, I wanted to welcome Fernanda. Welcome. Happy 2025.
Hi,
Hey, Fernanda.
Hey, everybody. Just making sure I was not on mute. Just
You are not on
reminding me.
mute. And we are so glad that you are here. And I know that you know this, but we're talking about trends and technologies and innovations shaping the future. And specifically, we've gotten into the renewable energy conversation. And Alan brings up some really great points about going to where the renewable energy is abundant. And then you also brought up another point about financials, right? Like the cost of it, not just the environmental impact and how much we're using, but the cost. So
yeah, so the point I just made, Fernanda, is that people tend to think when they think of renewable energy in terms of constraints, but you have to factor in also abundance. When the sun shines, when the wind blows, sometimes it's the middle of the night in winter here and the wind's blowing and nobody's running their air conditioners. You actually have abundant energy if you can move your workloads to them. And now you think of this, so the beginning of this topic was my panic over the rapid growth of AI and the huge overbuilding or huge building rate of new data centers, huge pace of building of new data centers. So I think the theme of this whole meeting panel is what's new, what's happening, and AI is got to be in the conversation.
So I have a few thoughts on that. First, just to remind everybody, I'm here under my own recognizance, and I do not speak for my employer. Always have to remind people of that. I think it's a good thing that the conversation about nuclear has come back. So for context, I'm a physicist. I've studied it, followed it. I understand people's fears, but I also know that there have been countries that have been running successful nuclear operations, and their, energy independence is strong. I also have observed us panic a bit every time there's an accident, mostly because the ones that suffer these accidents are reactors that are from, first gen, second gen, and we've moved far beyond that. The Department of Energy has a few things that they've done with small modular nuclear reactors, and I think those are really neat, technologies to come to life. And so the fact that if the worst thing, about AI is energy, I think the best thing about that to happen is that we're bringing nuclear back to a conversation, because it is a clean energy source that we can switch to, not overnight, because regulatory, all sorts of things need to happen. But we could switch to that really quickly and bring down our carbon footprint, overnight, right? Depending these things coming online. So if that's the best thing that can happen from AI, I'd be really happy with that, because I think that would be a good thing to happen. Renewables are great too, but it's not an either or, it's an and. And in my personal opinion, to get out from carbon, based energy solutions would be the best thing for everybody. I would just like to breathe better air,
I also liked, I think Jonathan kind of was talking a little bit earlier about like algorithmic efficiency. And, I just wanted to kind of follow on that conversation a little bit too, as well. I mean, I being a Linux user, that was one of the things that I always, especially early on when I first started using Linux, really kind of amazed me. And I was very interested in is, all these tools, that Linux provides that will run in a few, K of memory or less. and it's because during that period of time that, that was all you had the memory to, when these tools were being developed, it was like, that was the computer. Like, if you want these tools to run, you've got to fit them within these constraints. So since then, I'm sorry, I'm getting a little bit of an echo here. So, since then, of course, now, and I'm a culprit as far as this goes too, because I'm in the container community and I've pushed containers and stuff like that. And one of now it's like, oh, well, I just need this little tool that is really quick and easy to run, but I'll put an entire operating system behind it. And I'll, I don't really care how big the container is, whatever, it's fast to copy it from here to there because we've got, really nice networking capabilities. And I don't care if it takes extra memory because I've written an inefficient algorithm and, MATLAB or something. And, it's like my time is expensive and compute is cheap has been, I think, for a while, like the mindset. And it's because of necessity. I mean, maybe this is going to drive us to develop more efficient algorithms, and maybe we're going to save energy that way. I mean, we're going to kind of have to that's programmers are going to have to, in order to fit the training algorithms and the inference algorithms and things onto the kinds of hardware that they want to, right? So that's a good thing as well.
So Dave, do you think that building templates that are built with that in mind, so taking that away from scientists like you who would have to go do that, but actually give them a template is a good baseline of a place to start, of here is the minimal container you actually need. You don't need the whole operating system in it. Do you think that's something that somebody should focus on?
Yeah, but once again, it's like, what's the incentive? I mean, if we have, for all intents and purposes, limitless compute thrown at us, and like you can go, then there's no, scientists are a great example, because scientists always have 100 things to fit into 10 boxes as far as like their time constraints go. So they tend to be extremely inefficient programmers, just grabbing stuff from the postdoc that came before them and not really looking at it too deeply, and it's running 10 zillion things that it doesn't need to run in order to analyze your data, that are just kind of like those other things that it runs. When I first started in my in graduate school, I was learning to program, and I had another graduate student who was kind of mentoring me. And I was kind of going through some old code in the lab, and there was like in this one function I was trying to understand, I'm like reading through it, and there's like this for loop, and it's doing like all this stuff, and I'm going through and trying to figure it out. But then, like, hard coded, the iteration that it's on is on like iteration number 8 or something. And I'm like, what is going on here? I'm trying to understand what's happening. It's doing all this additional compute, but it's only on one iteration. And I went and talked to the graduate student. He was like, yeah, I mean, I needed it to do the 8th file or whatever. And I just threw that in really quick. And, that's so, like, you're incentivized actually not to go through and try to clean up code and optimize algorithms and do things like that, because you just don't have the time, right? So if the incentive is there because there's only, we can't go beyond some limit of energy or some limit of compute or some limit of whatever, then that's going to produce more efficient code just because the incentive is there. And then you'll end up with something like, the beauty of Linux that can run sorting and algorithms and can go find files and things like that with just a few K of memory, because when these algorithms were first produced, they had to be extremely performant, and they're still performant even on what they run today.
Yeah, I agree with that, and my bias is set from having done a lot of my early career coding exactly in that arena, making particle physics tracking code run better. I found, by the way, a useful social engineering technique when trying to get people to move to a new platform is to write code that's faster that also runs on the new platform. And when you put that into the code base, you've sort of got two jobs done at once. So, I mean, the theme of this call was supposed to be on predictions for the future, right? And I've put a link in. I don't know if you guys want to share it out over the broader conference, to an article in IT Pro Today, where they asked for development trends and predictions for 2025 from industry insiders. I don't know who's an insider. I guess someone who's in your contact base. But they almost all have something to do with AI. And I think it's worth maybe thinking about what Dave just said in that context. So part of our new project will be applying a lot of instrumentation that we developed and we've tried out on my clusters to identify inefficient code, interact with account holders on how to make it more efficient and so forth. And focusing that instrumentation, which is really sophisticated, on energy topics. but one can imagine, throwing AI methods into this mix. When we first got started automating data centers, we found a lot of the then popular advertisements from equipment vendors was AI powered data centers, or AI in the data center, and it was all mostly nonsense. They were talking about not producing AI, but using it to analyze and run the computing. And the problem was there simply wasn't enough information available from the servers. And then through some work that we got to participate in, the richness of the data set you can get out of a typical baseboard management controller or whatever just really drastically improved. Redfish, for example, which is now the core of our approach to automating data centers, could be set into a mode called telemetry, where you could get a couple orders of magnitude more information out. And then that's where a lot of our instrumentation came from. So what I called it then was precursors to AI. The idea was, you can't do AI unless you have enough information to work with. Now we have tons of information, and this was all done without instrumenting the code. So there's various methods of instrumenting the code. My favorite one is called Like I Know What I'm Doing, LIKWID. I think it's also a project of the HLRS folks. And so you have all this extra information. Can you now go back to Dave's suggestion and try to figure out how to apply this stuff to identify low performing code and maybe even suggest changes?
Brenda, I know you had some thoughts. You were saying industry is also just as inefficient as science.
I like to defend my scientists. They're not the only ones writing bad code. I mean, we had an entire world of Hadoop and Spark running on JVMs, and that's not efficient. We know that's not efficient. It got the job done. It's not like they try to reach out to us and be like, "Hey, do you have a communication library that we could use?" Because otherwise, we're just going to use TCP. They didn't come to us and implement MPI in their backends. So I'm going to defend the scientists here. Everybody's writing code that gets the job done. There are better ways to write code. Nobody needs to write the best way to write code. If you do, you're lucky and consider yourself, a genius, great. But most of us are just trying to write code that gets the job done. And if it gets the job done in a reasonable amount of time, then the job is done. For example, when I went to NVIDIA, my job was to bring people in the life sciences to GPUs. So we got people in the physical sciences to come in, right? That computing had been at the center of everything that they needed. You can't exactly simulate the universe on a supernova on a petri dish, but you need a supercomputer for that. But for folks that were doing, life sciences in biology, essentially, their world was R and Perl, and some of them worked on Java. And so I'm going around talking to universities, and I'm going around talking to researchers. I'm talking to anybody that will hear me and knock on their door and be like, "Hey, have you considered GPUs?" And so a really neat example is, for example, when you're doing genome assemblies, right? Genome assemblies are essentially like a week-long set of work, because it involves actually getting the sample, cleaning the sample, isolating the sample, amplifying the sample, where you have to duplicate all this DNA, you have to chop up all this DNA, and then you put it through a machine, the machine then reads it, and the last part is you've got all this data, and now you're going to play, puzzle with it, aligning these little sequences that have come along, these little chopped up sequences, right? And that part took 8 hours, 12 hours. So if I go to them and I say, hey, you can do that in 2 hours, 1 hour, they're going to be like, great. Now it still takes me a week. It doesn't change what it was doing. So like, do they have an incentive to make code more efficient? No, because the entire process takes them a week. And so, when people start talking about like, well, you need to write more efficient code, or maybe they're from the pulpit and be like, we should write better code. That's great, but AI should write better code, right? Like things that are really, really big and causing a lot of carbon footprint, they should probably invest time on doing that. Things that aren't, they probably shouldn't, and that's okay. It's not gonna make a dent. What will make a dent are us, getting industrial processes down, et cetera.
That's a good point.
Yeah, I'll reinforce that 5 years ago I bought a bunch of GPUs, and we embarked on a program trying to convert people to using them, and they really did not get heavily utilized until the beginning of last semester. And somehow a bunch of work throughout the software ecosystem, plus the interest in AI. It wasn't just people playing with Llama or something. A bunch of code that hadn't been ported to GPUs before started to show up and run on our GPUs. And so our GPU partitions have been completely utilized since about September. But for a good fraction of their 5-year lifetime to now, they were not. So now, of course, those 5-year-old GPUs are ancient, and I'm having to go back to the university and try to get resources to buy more. I'm just curious what trends and innovations shaping the future, since that's supposed to be our theme, you see coming out of this.
Yeah, one of the questions was about open source communities. There's so many of them. What are maybe some of the ones that you are, either involved with or kind of seeing come on the scenes? I feel like there's like a couple new that I'm aware of every day. I can't even imagine how many there actually are every day.
I just gave a talk at the lab about all of these new frameworks that have come out, just highlighting things that do interesting stuff. I was asked to give a talk about data engineering, essentially, and what industry is doing for data engineering, and that's what I was doing at the startup that I was. And I talked a lot about Apache Arrow. A lot of places have, implemented it. A lot of frameworks are implementing Parquet at the very least as their data format. It makes sense. If you haven't heard of Parquet, you should definitely look into Parquet. If you haven't heard of polars, you should definitely look into polars. If you haven't heard of Apache Arrow and ADBC, which is a new way to connect databases, not just databases, but just connect data in general, you should definitely look into it. For the most part, I think there's more momentum in the data engineering part. We've suffered for a long time. I do see some more momentum in just helping people put data engineering, pipelines together. Yesterday, I was looking at Hugging Face's data sets. So there are lots of different kinds of frameworks that have their own version of the data set. And I was looking at Hugging Face's, I was just perusing data sets for a workshop that we're putting together for the summer. And there, at the header of where each column is, so each feature, right? Columns, features, they're interchangeable in AI world. But for each column, they had a little thing at the bottom, so it had the title of the column, and a little thing at the bottom that talked about like ranges of the numbers that were there, or in a date it had like ranges of dates. It had like number of nulls, percent of nulls, and it just had a little bit of. And I've been working a lot on like just data cleanup for the project that I'm in, and I was thought that is so neat because just a data validation part is like huge chunk of work that you have to do for these AI workloads, ML workloads. And the fact that they had it there and you can kind of see the data first, and you can see like, is this going to be good data? Is this going to be something that I can use? Is this going to be something that I can reuse? And it was just a neat, simple interface that was amazing. And I was like, okay, is this open source? Immediately, I wanted to look at it. I ran downstairs to my basement. I, turned on my little Linux desktop that I have, and I downloaded it and I started playing with it. And there's a whole bunch of stuff that I still haven't gotten through because it requires Docker and all this other stuff. But I got so excited of just the data cleanup because it's such a painful part of everyone's workload. So I see data engineering, I see these workflows, I see a lot of streaming um, uh, uh, frameworks coming out and getting big, because the bigger the data, you can't just move it, you got to stream it in. That's how you start doing training. So a lot of vector databases, vector storage, vector stuff coming out. So I see a proliferation of just tools for data engineering before the AI workloads.
So this was like Open Refine for Apache Arrow, or what was the new tool that you ran into?
The
data cleanup tool. I've used Open Refine for many years for messy data cleanup.
Yeah, the one that I saw was called Great Expectations.
Oh, interesting.
And it's really neat because what you do is you tell what you expect for this column. Like I expect the example they did was they used the New York taxi data, which is a very common data set that people use for examples. And it said something like I see I expect 4 passengers for the number of passengers column. And it comes back and says, okay, fail, the test failed. So it's almost like a CI, thing. The test failed, and then it said, we saw 2 values that were outside of this, and then it lists, we saw 2 6s. So in other words, there were taxis out there that had 6 passengers, so the capacity for 6 passengers. So then they changed the expectation for that. They're like, okay, that was reasonable. They changed it, and now it passes. So that test passes. And I thought, this is neat because it makes, instead of me having to kind of visually look or just doing sums or just doing counts or just doing mins and maxes, right? And you have to, up until now, programmatically do it. I can do it in a sort of a test suite and say, I expect these values, and that's cool. What was the one you said you used, Alan?
Well, it's sort of spreadsheet oriented, not high volume data oriented, but it's called Open Refine, and it's been around. It was a Google product about 5 or 6 years ago. I think they open sourced it, and it's available for all platforms. I've used it in a wide variety of settings. You can teach it, different spellings of the same word, or just different data processing. Again, it's another example of a tool with, if coupled to AI methods in the back end, could be extremely powerful. I'm an AI skeptic, as you know, but I'm trying to look for ways.
Oh, we know, Alan. You hate AI.
I don't hate it. I just think it's, there are many negative things to say for every positive thing, but I'm still looking for the positive things. So I see that Great Expectations has a open source GitHub repository, though it's a commercial company.
Correct. Yeah, it's a commercial company.
But they have a
core. They're doing the sort of model that others have done, which is like we have the core piece of software, and then features that are a little bit more special are what we charge for, so that they get you started, which is.
Yeah, so that's my question: is can you find tools like this that were aimed at kind of manual intervention, and can you automate them with with machine learning and AI techniques? So the place we're going to be looking at is code efficiency, right? We can determine certain patterns that we look for manually now. Well, that means we can probably teach a machine to look for them. And what happens?
Yeah, I would love that.
Scale? Yeah,
I think that would be super interesting if we can find some use for where an AI or ML framework, and I would get into a ChatGPT interface and I'd be like, look, here's our Parquet data set, and here's what I'm expecting. I'm expecting these dates for all the columns that look like dates. And I'm expecting this range of years, and I'm expecting no names. I'm expecting no columns that will be less than 30% full with information, right, or more than 70% nulls, and then you just kind of describe what you want, and it turns it into, okay, I'm going to go look for this, and I'm going to run through it. I think there's the beginnings of that, and we're not quite there yet.
Okay, and OpenRefine, just for completeness, is just openrefine.org, and it's open source as well. So,
Thanks for sending those in there, Alan.
Is that enough of a trend in future? My guess is that even skeptics like me will find ways of applying AI techniques, but what we have now in AI is just autocorrect on steroids, and I am not impressed.
So I wonder if you're using AI for like big data selection or big data cleaning. So I guess the types of things that I think that AI works really well for are things that are tedious, and then like at the end, after your AI has created some sort of a solution, you can sort of check the solution against a known, good version. How would you do that if you're using AI to validate a data set or clean a data set? Like, how would you perform some sort of a sanity check to make sure that it didn't just delete a bunch of good data or change a bunch of values or something?
So that's remember, we don't have to do an either or, right? We can do both. For an initial sanity check, I got something that was just sent to me. So I'll give you an example of something that I was working on. We got something sent to us, and we were expecting a particular type of data that every other package that has been sent along, that type of data existed. And let's say that it was images. I expected a zip folder full of images. That didn't come in. And so I could, if something could then go check that and figure it out that it was there or not there, great. It can flag me. And then I go like, oh, I got a flag. Let me go check. Now I can do this programmatically, right? Like I can check, but each of the file names are different, and the dates are all over the place, and not all things are named consistently. And so it's not like I can just say, is it a .jpeg? Sometimes the images might not even be consistent in the format. Again, I can still programmatically do that. But this is the sort of tediousness that would be great. If I can teach an AI to be like, do you see any images in that folder? And the AI goes, no. Okay, let me go check. And now I've triggered something that I can then more, formally do the sums and the mins and the maxes and the counts and the nulls and the whatever, right? And then double check. But if I see something wrong immediately, like glaring, then why not?
Yeah, I agree with that. I think, if I just think about how I write a bash script to go, do some task for me, it's usually iterative. I say, now give me all those things that actually look like the result of this step. And then I say, there's just a general way to do this. Ideally, AI would be a partner in these kind of tools. You would go through the data and say, well, this is the same as that. That's the same as that. This is different than that. And the AI would be kind of over your shoulder learning from you. But Dave, I think the answer to your question is, if you would ask, that you will actually have to do a check. You won't ever get rid of that step. And in fact, if you ever do, it's probably a recipe for disaster. We all know that we can automate really stupid things. I'm trying to avoid a university administration joke here.
So, some things you can't fix, even with AI.
Wow, you guys, we have been chatting here for quite some time now, about 45 minutes. And I think that we could probably go on and on and on, but it might be a good time to kind of wrap up. Dave and Jonathan, if there are some, open source things that you want to talk about, it definitely is exciting for me, even though, it's like, it kind of feels like old news sometimes, at CIQ, it's like, yeah, we support Aptainer. It's an open source project. We support Werewolf. It's an open source project. It's really cool. Also, there's another one, Ascender, that's also an open source project, the automation platform. And then, of course, Rocky Linux, which is also open source. But it's actually interesting that just about every single day, there's someone that crosses my path who has never heard of one of those, right? Who is totally new, doesn't really understand, wants to know more about it. I mean, it's kind of changing a lot, certainly with Rocky, more and more people are knowing about that as the years go by. And then of course, Aptainer as well. So really the influx is more about people with Werewolf going, wait, what is it? Like, what can it do? This is really exciting. So there definitely is, there's so much more on the horizon, and yet there's so much that is already going on, and it's growing and changing every day. So yeah, I just wanted to give you guys a minute to speak about that, and then wrap up your thoughts, and we'll kind of go around, and I'll just point. Dave, you're first.
Cool. Well, just as a aside too, I saw Alan kind of pointing to the, I assume, Rocky Linux box behind him. I just want to also share in geekdom that yeah, I've got like I've got all my peripherals and everything, the mic, the new thingamajig, everything. This is a Rocky Linux laptop too that I'm streaming through and doing all that kind of stuff. So yeah, Linux has come a long way since plug and play didn't work for anything. But
Y'all are shills. You're shills for Rocky Linux, all of you.
Yeah. As far as like the open source community and news in the open source community, I can share a little bit of news about Aptainer. So Aptainer's been a member of the Linux Foundation for several years now. Last year, we also joined another organization which is under the umbrella of the Linux Foundation, which is the HPSF. The High Performance Software Foundation. And, that is kind of gaining some steam, and we're getting rolling with that a little bit. And we're starting to do things like have like community meetings planned and things of that nature. So in May, I don't know the exact date off the top of my head, but coming up in May, the HPSF is planning a user group meeting in which all the kind of projects that are underneath of that umbrella are going to be represented. And so Aptainer will be there, and that's going to be in Chicago. If you go to the HPSF website, I'm sure you can get more information. And yeah, there's going to be a Aptainer user group there as well. So, that's something cool that we've got coming up that's part of the open source community in the new year.
Ooh, that's really exciting. Thank you for sharing that. What's the month? What month you said? Oh, October?
May.
Sorry, May. Thank you. Chicago in May. Dun, 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 dun. There should be a song. Thank you, Dave. And thanks for all the good work that you're doing there. It's exciting.
Yeah.
Jonathan.
Yeah, I mean, broken record a little bit, but there's exciting stuff coming for Werewolf for sure, both with the Community 4.6 release, hopefully in the next month or so. But then CIQ has also been developing some add-ons, some of which will go into the community, some of which will be CIQ stuff that I'm excited to hopefully show probably here in the not too distant future. So I hope people will watch this space for usability improvements and kind of easier on-ramping to getting started with Werewolf and making it more observable.
Jonathan, I just had a fun thought. I don't think there's a Werewolf user group, but if and when there is, it will be wug.
Wug. Just call it wug.
Wug.
There's the Werewolf Slack team, but that's the closest thing.
Okay, that was fun. Thank you for all your good work there as well. And Mr. Allen.
Well, I just want to give a shout out to the single board computing cluster competition, sbcc.io, which is open to everyone, and you're welcome to join. It's basically a competition for small single board computers turned into clusters. No Apple M4s allowed, unfortunately. No commercial hardware. And it's really just an international training and outreach project. And we're certainly contemplating what we should do in that arena. I'm a big fan of these little clusters that cost from a few hundred to a few $1,000 you can hand to a student, and they can learn how to do everything on your main cluster, which costs a lot more than that.
I really want one. It's such a cool project.
Yes. We'll teach you how.
I want to give one away at the next SC.
Oh.
Just saying.
Let's loop back. So Jonathan Rose, let's talk, and I can teach you everything you need to know The only caution is that it's addictive.
Well, it's got to have Rocky on it, just saying. But yeah.
Yeah, they do. Yeah.
Awesome. Thank you, Alan. Appreciate you.
Okay. Bye.
Fernanda, final thoughts?
Final thoughts. I've been building a home lab, and it's still in the furniture. I've got cabinets on the wall phase. I finally got a 3D printer that's legit. Got one of those nice little bamboos.
Nice.
And hopefully I can get it cleaned up enough and things put away that I can start documenting some of the stuff. But my hope is that I can do these sorts of things, which is in the lab, maybe show off, hey, I just learned about this great tool, like Great Expectations. Here's what it does. And show it off to an HPC community that may not be necessarily looking for this stuff. And not just because it's HPC. I think all of us tend to get very stuck on the tools that we've used. Like there's a reason why pandas continue to exist as pandas is because, well, it's familiar. It's got all the features that we want. Like nothing is missing, right? And so I would like to do a little bit more. And so maybe I'll put some Rocky on there and start from there. So Alan, share your little computer thoughts so I can put together. I mean, I have odds and ends computer right now. It's just, and GPUs galore just everywhere. It's going to be very Frankenstein looking, but that's part of the fun.
Yeah, it is. So my razor has been, I've been focusing increasingly only on things that I can use to teach our students and staff how to do things exactly as we do them on the main cluster. So I'm focusing on processor types and GPU types that we have in the main cluster, just cheap implementations of them, so that I can, have a Kleenex box to, monitor size cluster on somebody's desk that they can get started with.
Oh yeah, that's great.
It's really cool.
All right.
Awesome. All right, everybody. Well, thank you so much for being part of the, what do you call it, Alan? The inner community?
Insiders.
The insiders.
We're insiders. Yeah.
Y'all are the insiders. Exactly.
I am not an insider. I'm definitely an outsider. I'm just trying to bring people, more outside. That's my goal. It's like, come with me outside. Let's not stay inside. Let's go outside.
Fresh air out here. Let's go. Let's party. Awesome. Well, thank you guys so much. There's a lot of links for all you watching out there, lots of different links in the chat there. So you can follow along in the conversation and check out all the different open source projects and the cool things coming up and all of these different areas. Thank you so much for being here. You want to contact CIQ for more information about all the amazing things that we're doing with Apptainer, Werewolf, Ascender Automation, Rocky Linux, Fuzzball, all these cool things. Oh, yes. And the last little plug for Dave Godloves. Next week, he's having a live webinar. So at this same time, 11 Pacific time, next Thursday, January 23rd. That's something that you're going to have to register for. And the registration link is on our website and, of course, below in the comments. So again, thank you all so very much. And it's a pleasure seeing you for the first time again in the new year. And we'll talk to you soon. Bye-bye.